Hey, Vlad here, devinsideyou.com. Welcome to another video. Today we're going to dive into the world of compiler flags, warnings, and linters. It's a very hairy topic, so let's not waste any more time and get right to it. Lately, there have been quite a few awesome blog articles related to configuring warnings in the Scala compiler, making them fatal and whatnot. I'll have a couple of links in the description below. Now, in case you've noticed the uprise of such articles, you might be wondering why, or at least why now. So let's have a tiny history lesson, shall we? Pretty much since the beginning of Scala, the Scala compiler had many flags or options, some of which were related to linting, warnings, and converting warnings into errors, etc., etc. They weren't widely used though, and there were three reasons for it. Firstly, for a very long time, it wasn't possible to suppress warnings, which made them a hard sell. Which brings me to the point number two. Some of these warnings were causing false positives, warning you when they shouldn't have. This either happened due to implementation bugs or simply because they could never be sure. They're warnings and not errors for a reason. And thirdly, new flags are being added and removed constantly in pretty much every new compiler versions, even the patch versions. I'm recording this video in the end of 2020, and most of these issues are resolved by now, or at least there are workarounds, which explains the uprise of such blog articles and even this video. Firstly, at some point the silencer compiler plugin came along, which allowed you to suppress warnings. And lately, since Scala 2.13.2, the Scala compiler even has a built-in way to configure warnings very granularly. It is so new that it hasn't even made its way into Scala 3. There is already an issue though, and hopefully it's going to arrive together with Scala 3 because it's super useful. Secondly, Rob Norris, aka TPolCat, a Scala veteran who is, among other things, the author of the libraries like Doobie and Scala, published a list of the compiler flags that he was using. This list became a de facto standard recommendation. I'm pretty sure that even to this day, if you Google for something like Scala flags, you're going to find his article. It was so popular that someone else even took it and created an SBT plugin out of it, which would even take care of the flag differences between the Scala compiler versions. And the third reason why things got better is because these days there are also other linters available. Some of them are old, some of them are new. There's, for instance, Scalastyle, which is not tightly integrated into the compiler. It is simply a command that you run and it gives you a report, and then it's up to you whether you're going to act upon it or not. There's also a tool called Scapegoat, which pretty much does exactly the same thing. Then there are other tools which are more tightly integrated into the compiler. Tools like Scalafix, which is a rewrite tool, but it also comes in with its own linter. In fact, a year ago or so, I made a video about Scalafix. You might be interested in checking it out, but probably at this point it's a bit dated. Yet another tool determined to save you some trouble is WartRemover. In fact, this entire video was supposed to be about WartRemover, but I couldn't resist to dig deeper, and so here we are. And now you, same as me before I prepared for this video, are left with a bunch of questions. I've actually written a couple of them down. Which tools should we use? Which flags should we use? How to migrate from one compiler version to the other? How to selectively turn warnings into errors? How to turn them all off when they become too distracting, and you won't believe how fast this actually happens? How to make sure that when we're on CI that they're actually turned into errors, since the CI job is going to fail? And many more questions like this. Well, have no fear, Vlad is here. If you've been following me for a while, you probably know that I have my own Jitterit template that creates a pretty much hello world Scala project. It's called Scala Seed, and lately I also have a Scala 3 seed for the upcoming Scala 3 version. Now, I already have a video about Jitterit. In fact, it's 3 videos, and I also have a video called How I Set Up My SBT Projects, in which this template was created. In any case, I use this template for both my real projects and when I record videos. And when I record videos, I don't want to have linting because it's going to be way too distracting for you, right? And so usually in my videos when we're playing around, I'm always creating a new project, and the first thing I do is I go to the build file and I start changing it. You know, I start disabling the linting and stuff. Well, I finally sat down and set it up in such a way that not only can I have my cake and eat it too, but you can as well. We're going to go through the change set in a second, and I'm going to show you every line. So it's going to be like a little bit like an SBT tutorial. And then afterwards, I'm going to show you how to find all of these Scala C flags, how to choose the WartRemover warts, this is how they're called, and so on. So I'm going to show you how to find like all of these things. Before we dive into the change set, allow me to summarize what it actually does. The first thing that it does is that it enables all kinds of linting available in the Scala compiler, and also all kinds of warts, right? So we have all the linting from the Scala compiler, and we have all the warts from the WartRemover plugin. I haven't played with, I haven't added, Scalafix or, Scalastyle or Scapegoat or anything like this. Okay, so we just have the Scala compiler flags and the WartRemover warts. The second thing I did was I used the SBT rewarn plugin, and all it does is it makes sure that the warnings are always re-displayed, because usually the SBT's built-in incremental compiler called Zinc, it usually only displays the warnings of what it compiles, and by its incremental nature, it always compiles less and less and less, and so warnings kind of gradually disappear. And so this SBT rewarn plugin changes the reporter in such a way that the warnings are always redisplayed, even from the stuff that you don't compile. Seriously, I wish that I knew about this plugin before. It's insanely helpful. It's a lifesaver when you're migrating from one Scala version to another, and there are a bunch of new deprecation warnings and so on. The third thing that it does is it reads out an environment variable, which I called lint off. And if the variable is set, then it's simply going to turn the linting off. And this is going to be the variable that I'm going to have set up in my WSL distribution that I use for recording. And so over there, I can just use my template. The variable is set somewhere behind the scenes, in my ZSHRC or something. And so linting is off. But for my real projects, I'm going to use the same template, but the variable is not going to be set. And so I'm going to have my linting. And obviously you can use this too, right? So if you use my template, first of all, you can fork it and you can change everything you want. But if you're just using my template, you can also just set this environment variable. If you get tired of the compiler, barking at you all the time, it gets very, very distracting. If you enable all of the linting rules, all of the words, you can't even write like one line without the compiler barking at you. By the way, I have an awesome video about a tool called dir-env, as in directory environment, which allows you to load and unload environment variables based on the directory you're in. It's a lifesaver. Check it out. Another, by the way, if you're managing your environment variables with a tool like dir-env, or if you're using some other mechanism, in any case, the point is, if you're changing them all the time, don't forget that they're being read out every time SBT loads, or if you're a Metals user, then every time you're importing or re-importing the bloop build, okay? Because otherwise, the environment variable is not going to be read out. Now, the fourth thing that it does is it reads out the CI environment variable, which is a convention. Most continuous, probably all continuous integration servers, they expose this, they set this environment variable called CI. The value doesn't really matter. In fact, it is so common that there is even a setting built into SBT that reads out this environment variable for you. So I didn't even have to do anything. Now, when my template sees the CI variable, when it sees that it's set, then it does three things. The first one is it doesn't even bother checking the lint off variable. Okay, so the CI variable has priority. The second thing it does is it always enables all of the linting rules and all of the word rules. It is configurable. I'll show you to you in a second. And the third thing it does is, because we're in CI, it actually converts all of them, all of the Scala compiler flags and all of the WartRemover warts, and converts all of them into errors. Now, there's also a fifth thing that we're going to do, but unfortunately it cannot be built into my template, and it has something to do with Git hooks. If you've never heard about Git hooks, Git has a built-in mechanism called hooks. Every time you init a repository, inside of it there is a tiny directory called hooks, and if you look inside of it, it's regular scripts. They all have the .sample extension, so that you can take a look at them and use them for an inspiration. But essentially, you create scripts like this with exactly the same name without any extensions, and they're called the way like pre-commit or pre-push, and these hooks, they have the ability to intercept your commits or pushes, and they're very, very simple scripts. You can put in whatever you want in there. If the script returns a 0, then the commit or push is going to succeed. If they return anything else, it's going to fail, right? The commit or push is going to fail. And so for the cases when let's say the warnings got too distracting and we set the lint off variable, and now we don't have any linting, and now we're working for a couple of days, we forgot about this whole linting thing, we have our commit, we rebased a couple of times, we're ready to push, and now we're going to have a tiny pre-push script, pre-push git hook that will simply pretend as if we were on CI, right? So it's simply going to export the CI variable. It's going to set it to whatever, it doesn't really matter. As long as it's set, it's going to be grabbed, and then it's just simply going to do SBT test compile. What this is going to do is going to first of all turn on the linting on again, and it's going to convert all the warnings to errors, and therefore if there is even one of them, the whole script is going to return a non-zero value and the push will be aborted. There is a caveat to it though, and depending on your workflow, it actually might be a showstopper for you. Basically every push is going to be equivalent to an SBT clean compile, right? So your pushes are going to become slow. But if you don't push that often, like, it really depends on how you're working, then it's still going to be faster than waiting for CI. All right, now let me show you how I did it. And as a reminder, I also have a template for Scala 3. However, because some of the settings are still missing in Scala 3, I didn't push that change set yet. Okay, so this is a change set. The commit message is descriptive as always, adds warnings, linting, and the lint of variable. As you can see, only 4 files were changed. In fact, 2 files were added, like this file and this one. As a reminder, this is a change set to the template, and if you have never seen Jitterate, then for now just ignore the source main G8 variables. Okay, just pretend like if this was the root of our project here, 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 and here. As you can see, most of the changes in this change set were actually additions, which is really good. So the first one that we're going to look at is the plugins. Okay, so as already mentioned, I added the rewarn plugin and I added the WartRemover plugin. And by the way, WartRemover, at least the WartRemover, I'm not sure about rewarn, but at least the WartRemover is also a compiler plugin. So if you're not using SBT, if you're using Gradle or something else, you can still use the compiler plugin. Now let me collapse this. Okay, so the next one is this scalac.scala file, and if you're not super familiar with SBT, the way this works is that if you go like in a layer, SBT is recursive, it sort of built itself, and so if you go like to a layer below, like to project, and if you have a .scala file in there, and then if you have some, I don't know, an object in there or a val, then if you go like a layer back, then you're going to be able to use it. And so I'm going to open it in a second, and inside of it I have an object and a couple of vals in there, and they're simply there because I want to use them from here. Okay, so I called it scalac.scala, and now a layer above I'm going to be able to access these variables in a .sbt file. Okay, so let me open it. It's just this thing. Please ignore this for now. We're going to talk about this later. So for now, concentrate only on these two. Okay, so it's just an object, inside of it 2 vals, both of them just sequences of strings. The first one is the linting options that I chose, and I'm going to show you how to find all the others. So if you're not interested in turning all of them on, you can decide for yourself and put in whatever you want. Okay, this template is still going to work. Okay, and the other one is just the fatal warnings. It is also put into a sequence just so that it's a little bit easier. Okay, so for now, let me actually show you where to find these flags. Okay, so let me go over here and I'm gonna open DIY, which is my I'm using WSL. I have a video about WSL. So this is Ubuntu 20.04. So for this you need the Scala compiler, and the easiest way to install the Scala compiler is by using a tool called Corsair, and I also recently made a video about it. Okay, so if you have the Scala compiler installed, then you can do Scala C. Okay, and as you can see, I actually don't have it installed, but I do have CS. Okay, so I can just do CS install Scala C. All right, so now I can do a Scala C version like this. Okay, now what Corsair also allows you to do is it allows you to launch a version of the application without installing it. Okay, so without this, so if Scala C was not installed, in fact I might actually uninstall it. Uninstall Scala C. Okay, so now if I do Scala C version, it's not going to work. Okay, so instead I can do CS launch, and again I have a video about Corsair which explains all of this. Okay, and I can say, okay, please give me the 2.13.4, okay, and pass these parameters to it, version. Okay, and it's simply going to work out. Okay, and so now I can also do the same thing for 2.13.3, for example. Okay, and I can do the same thing for 2.12.2, for example. No, 12. Okay, 2.12.12. This was the latest 2.12 one. All right, so let's go back to 2.13.4, and we're going to not pass actually anything. We're simply going to launch the compiler, and by default, it's simply going to display the help. Okay, so if I go up over here, we're going to see that at the very top there is this one, W. Okay, so if we run this flag, then it will actually print a synopsis of warnings and options. Okay, so let's actually do this. So let's pass in the W. All right, and here they all are. Okay, let's go to the top. We're over here, and as you can see, here are all of them. So Wconf is this very new one, the one that I mentioned that got introduced in 2.13.2, and we're going to talk about this a little bit later. All the others are pretty much all of the warnings and linting, and it's a bit hairy because like some of them they kind of look like there are 2 ways to enable them. Like for example, if you go down and you see xlint unused, what it actually does is it enables the -w unused, but only a couple of them. The imports, privates, locals, implicits, and no warm. But if you go up over here, then you're going to see that the W unused, there are actually more. Okay, So I didn't really want to, to worry about this. So I simply enabled all of them. If we go back, I just said, enable all of the linting ones, enable the value discard, enable, all of the unused ones, enable that code, and so on. Okay. Again, if this is too much for you, I've just shown you how to find them. And also, let me actually demonstrate something to you. I am going to do this, okay? And over here, so we're going to do 213, let's do 213.3 over here, okay? And let's do 213.4 over here. Remember, I told you that the flags are changing even in the patch version. So let me show this to you, okay? So so for now it looks the same. I'm going to do page up over here, and I'm going to do page up over here. And now you're going to see that over here there is stars align, and the next one is constant. But if you look over here, there is stars align, and there's a new one in the patch version. In 2.13.4, there's this new one called strict unsealed pattern match. Pattern match on an unsealed class without a catch-all. Okay, and now because I'm doing this, when I'm gonna update the version to 2.13.4, which I already did by the way, then I'm gonna benefit from this new flag, and I will not need to change anything. All right, so these were the flags, and again, like ignore these things for now. Let me actually go to the build file, and I'm going to show you where these two are used. These are not the only places where they're used, but still. Okay, so I'm going to collapse this. I'm going to go to the build file. Okay, so I did two things. Like first of all, I had like these typical compiler flags. I took them out and I put them into the Scala C file. I'm going to show this later too. Okay, so I removed that. The second thing that I did was these two settings there for console, for compile console and for test console. Okay, and what they were doing, notice there's a minus over here. They were simply disabling a couple of linting ones, the unused and the fatal warnings. And now I just converted them to these variables, right? So as you can see, there was this Scala C object inside of Scala C. Okay, so there's an object Scala C. Inside of it, there is a regular val, and this is exactly where it is used. Okay, Scala C.lint plus Scala C fatal warnings. So this is now a sequence, and we're removing this sequence from the console flags. Okay, and this one actually there's no change. I simply inlined the second line. Okay. So basically, I'm saying that for the test console, it should use exactly the same parameters as for the compile console. Okay, so now I'm going to show you the last file, and this is the most important one. This is where the meat is. For now, just remember that this octotree plugin annoys me. In fact, I'm going to pin it like this. Okay, so that it just doesn't pop up all the time. Just notice that this one, like I used to use deprecation and I used to use feature, and now because there is wconfig, there's wconf configurator for warnings built into the Scala compiler, there is no need to do it this way anymore. We're going to talk about it in a second. So let me collapse this and let me open scalac.spt. Okay, so this is a brand new file. Okay, so the first thing that it does is it moved these options. Okay, and as you can see right now, the only things that are left are language and macro annotations. If I open this build file again, see there were more, and the only ones that are left is micro annotations and language. Okay, like the others are gone. Okay, now the next thing that it does is this. I simply forgot to edit. Like I should have had this from the beginning. Ignore this one for now. It technically doesn't belong into this change set, but in any case, okay. After this, it adds the value of the warnings settings, and after that, it adds the value of the lint settings. Okay, so both of them are the settings that I created, and I should probably create an SBT tutorial at some point. I'm not an expert myself though. Every time I'm just like Googling around, figuring it out, and then once it works, it works. All right. So if we actually go to the Scala C file again, remember I told you in the beginning to ignore this part. Well, now you should stop ignoring them. Okay. So the way SBT works is that you define these settings keys or tasks keys, and only later you assign value to them. If you think about it, it's actually not really functional. But in any case, so we're just I just created a couple of settings keys. Like this one is called lint, and it's just a sequence of strings. This is warnings, just a sequence of strings. And we're going to talk about this one a bit later. It's just a Boolean, whether it should lint or not. Now, if you look over here, so we're basically adding sequences of strings over here, right? And there is a chance that they will be empty. This is how I turn like warnings off and stuff. Okay. So now here's where we assign the value to the settings key called warnings. Okay, so we're basically saying, okay, so if we're inside the CI, and this is the one that I told you, this is the one that is built into SBT. In fact, I have it open. This is the change set where it came in, and as you can see, it's actually from 2017, so it has been around for more than 3 years. It simply checks if the CI variable is set, or if the build number variable is set. Okay, so I didn't even have to do it on my own. If we're on CI, then we're going to use this new Wconf configuration thing that we're going to talk about in just a couple of seconds. And we're basically going to say that whatever we encounter, we're always going to convert them into errors. Now, for some reason, this was not enough for the WartRemover, so I also used the the older X fatal warnings flag. Okay, and it seems like WartRemover was happy with that. Okay, so all the WartRemover warts were turned from warnings into errors. Okay. And otherwise, if we're not on CI, then we're simply going to say whatever we encounter is simply going to be a warning. And by the way, I'm going to explain the syntax in just a second when we're going to talk about Wconf. Okay, so now we understand how this value comes to place. And now let's talk about this one. Okay, so this one is over here. So this one actually uses another setting, the one that I created as well. It's over here. Remember, it was a Boolean. Okay, the third one. This is a Boolean. Okay. Now it basically says, okay, if it's set, and we're going to see what the value of it is a bit later. It's over here, but let's not look there. It basically says, okay, if we should lint, then please use these lint compiler flags, and these lint compiler flags are again over here. They are these ones, and you can change them, right? So you can decide whatever you want, but this complete mechanism is still gonna work. Otherwise, it's just going to be an empty sequence. And at the bottom is a similar thing for the WartRemover. If we should lint, then please enable all the warts. And a bit later, I'm going to show you how to choose them selectively and where all the warts are. And otherwise, just leave this setting alone. Okay, just take the value, whatever the value was there before. Just keep the same value. Okay. And now the most important one is how it decides whether it should lint. Okay, so as I already mentioned, if you were inside if we're inside CI, then this takes priority. Then it doesn't even need to look at the lint on variable. And if we're not on CI, it's going to look if linting is on. And how is it going to figure out if linting is on? Well, simply if it is not going to find the lint off variable. Now, usually it's not common to have variables or Boolean things to have them in like a negative way, right? So usually you would have like a lint on variable instead of lint off. But in this particular case, it works exactly like I wanted it to work. All right, so now let's talk about this Wconf thing. Like this is this new thing that came in 2.13 and 2. Okay, so I don't need this one. I don't need this one. All right, so if we just run the Scala compiler again, like this, then if we scroll up a little bit, and we're gonna see, oh yeah, it was inside of W. Okay, all right, so we need to do W. Okay, and the first one is over here, Wconf. Okay, so if we do instead of W, if we actually do Wconf and then we do :help, okay, then we're going to see a very, very good introduction to this thing. In fact, we're just going to go through this together, and you're going to see that it's actually very, very simple. Let me also show you that, again, it's available in 2.13.3. It is available in 2.13.2. And in 2.13.1, it just wasn't there. Okay, again, it has to download it real quick. Okay, but in any case, it says bad option. Okay, obviously 2.13.0, it wasn't there. Okay, and even before 2.12.12, it also wasn't there. Okay, so basically, if you want to, one of the advantages of this Wconf thing, which is this global configuration thing, is that you can now suppress warnings. And so if you're, I don't know, if you're a Spark user and you're still on Scala 2.12 or even Scala 2.11, then check out the silencer compiler plugin. It's gonna, it's gonna save your life. All right, so let's go back to 2.13.4, which came out just a couple of days ago, actually, and let's scroll up a little bit. Here, this is where it starts. Now, this documentation is literally so good that I can pretty much just read it out to you. Okay, so this whole thing configures the compiler warnings. Okay, so you can do it in your build file as we did, or you can also, it's described later below, you can go into your Scala code and use some annotations to suppress some warnings. Okay, and by the way, in the end of the video, we're actually going to use my template, and I'm going to show you all of these things. All right, so this is the syntax. You say Wconf and then colon, and then you have filters. Notice that it's multiple filters, and then a colon, and then an action. Okay, and then you have a comma, and then you have again, a bunch of filters and then some action. Okay, as you can see, multiple filters are combined with and. For example, filter this and filter that. So for example, in my build file, what we're doing is something similar to this. We're saying wconf and then colon any, so this is the filter which says, whatever you encounter, turn it to a warning. Like in this particular case, it's actually warning verbose, which will print the warnings with a category site, and for deprecations also the origins and since version, since when it was deprecated. Let me actually go back real quick and I'm going to show it to you. Okay, so this is what we're doing over here, right? Wconf any warning, and if we're inside CI, then we're doing any error. Okay, let's go back. All right, so these over here, they're all filters, but we're going to ignore them for now. Let's skip this section for now. Okay, so these are all the actions, right? So over here, the action is warning over here, and over here the action is arrow, for example. Okay, but there are others. Okay, first of all, there is also a short version for them. There's like E for arrow, W for warning. There's also warning summary, and warning summary is the thing that you usually see for deprecation. Let's say you have 3 deprecation warnings, and then by default the Scala compiler, instead of actually showing them to you, it will say, hey, I found 3 deprecation warnings. If you want to see them, then add the deprecated flag. This is what you would do in the past. Okay, and then you would add them, and then it would basically turn them into the actual warning and not the warning summary. As we have already seen at the top, there's also warning verbose, which also shows the category, and the categories they're pretty much important when you want to suppress entire categories of warnings. Okay, there's also info. I don't think that we had info in the past, but now you have it. So essentially, it's not going to be red, it's not going to be yellow, it's just simply going to be white. Same thing, there's a summary and there's a verbose version, and you can also silent them. Finally, we can silent the warnings. Okay, and now as you can see over here, the default configuration is that the category deprecation is going to have the warning summary, WS. The category feature is going to have the warning summary, and also the optimizer is going to have the warning summary. Okay, so this is the default configuration, and which is why I removed, if you remember, I told you that over here in the build file, I removed deprecation and feature because this one will enable them. Okay, I tested it. All right, let's go back. Okay, so user-defined configurations are added to the left. The leftmost rule match matching a warning message defines the action. Okay, so essentially, if you have whatever is on the left takes precedence. Okay, so if we had like category deprecation as a warning summary, and then over here we had category deprecation again, and it would be warning, then the warning summary would actually win. Okay, here are a couple of examples. For example, change every warning into an error. This is what we did, but again, it wasn't enough for WartRemover, so I also added the old flag, the fatal warnings. Okay. Over here, we're silencing only certain deprecations. Okay, so we're saying, okay, the origin of the deprecation, it should be some, and it's regex. So I didn't show you the filters, but it's essentially regex. So we're escaping the dot and the name of the library, and then again we're escaping the dot and then another dot, and then there's a star, and then we're saying and because we can have multiple filters, and since is another filter. It's actually this one over here. Okay, and then if this is the case, so if since is greater than 2.2, then the action is going to be asked, which is silent. Okay, in fact, maybe actually let's go up. I wanted to go up and actually show you the filters. Okay, so you can you can match anything. You can match a category by doing something like this. You can you can match a regex, and very important, it's only you only need to match a part. For example, if it tells you variable x is unused, if you just do message equals unused, it's going to find it. Okay, okay, site where the warning is triggered, so you can disable like entire packages, source file, origin of the deprecation, some external package, and also since. Okay, so over here you can do like smaller equals and stuff. It's really great. Okay, so you can have like very granular control. Okay, at the bottom of here you have also the list of all the categories if you want to suppress warnings by categories, and also again like as it was already saying in the beginning, you can also do warning verbose, and then you're also going to see like the categories being printed out for the warnings that you're using. Okay, now at the bottom we also have this one: to suppress warnings locally, use the Scala annotation no warn annotation. It also has parameters, right? But if you don't specify parameters, it's simply going to suppress all the warnings for this expression. Okay, we're gonna actually play with this in just a second. Okay, and also a tiny note that on the command line you would escape a couple of things to use the star in the end. All right, so now let's actually go into my dev folder and let's actually create a project based on this template. I'm simply going to call it playground, and we are inside of dev inside you. So this is my distribution, the one that I usually use to record my videos. So on this one, I actually don't want to have any warnings. So I actually already have this lint of variable set to something, and then as a reminder, the value doesn't really matter. As soon as it's set, it's basically true. Okay, and so now if we go into, I'm going to open Playground with Visual Studio Code. All right, like this. There we go. Let's open this one. Metals is going to wake up in just a couple of seconds. It's going to ask us to import the project, and we're going to import it. Okay. In the meantime, we're going to show the logs. We're also going to go to the terminal, and we're also going to start as BT over here. Okay. And so, in fact, I'm actually realizing right now that maybe the first project that we should create should be without the lint off variable, because over here, I want to show you that we're not going to get any warnings. So the first one that we're going to actually work on is we're going to do exactly the same thing in my other distribution. Okay, so I'm actually going to go and, ooh, that's interesting. Class not found. What? What? Oh yeah, so this happens sometimes when you're importing the build and starting SBT at the same time. Okay, so I'm just gonna press enter and everything's gonna be fine. And there we go, everything is fine. Let's run the test, for example. Okay, and let's also run the application. Oh, okay, we have hello world like this. There we go, beautiful. Okay, and now if I'm gonna save over here, Metal is gonna do this. Everything's gonna work fine. Okay. Great. So, okay, let's actually create even more space like this. All right. So let me go over here, and I'm actually gonna launch Space, which is which is my workspace. This is the one where which I usually use to prepare my videos. Let's go to the dev folder, and let's also do the same thing. G8, dev inside you, Scala seed. By the way, G8, jitter rate is built into SBT these days. So if you don't have jitter rate installed, for some reason, it's super easy to install with Corsair. Just do CS install jitter. But if you don't, you can just do sbt new dev inside Scala seed, and you also need to do .g8. Okay, so let's call this one playground. I'm going to call it playground space just so that so that we know the difference. Okay, playground space, come dev inside you. Okay, dev inside you. All right, so let's open it with Visual Studio Code as well. In fact, right now I'm actually going to run into an issue because I'm using WSL, and if you have seen my video about WSL, we're actually going to run into a tiny issue with Bloop. Okay, because both of my WSL instances, they're running on the same IP, and so Metals is going to be a little bit confused to which one of them to connect. Okay, in any case, let's show the logs. Let's see if everything is going to be fine. It seems like it's fine. Yeah, okay, so this is exactly what I meant. It says missing valid bloop build. All we need to do is we simply need to restart the bloop server. Restart the build server. Okay, disconnected from bloop and attempting to connect. And now we're going to connect and everything is going to be just fine. Okay, like this. Let's go into main. All right, and let me do something like private val n equals 1337, and we should already see a warning. Okay, so I'm actually going to go back over here. In fact, it's going to be very hard for me to switch back and forth again because of this WSL issue. So we're going to stay over here for a bit, and then I'm going to copy paste all of this to the dev inside you machine, and you're going to see that none of the warnings are actually going to be there. Okay, and by the way, this thing, like usually the warnings are not displayed like this. In fact, maybe I should also display the warnings over here. Okay, so this is the warning. Okay, this actually comes from another plugin called, I believe it's called Arrowlands. Okay, this is just a general VS Code plugin. Whatever language you're using, as soon as there is as long as there is a language server protocol thing enabled, then you're just simply going to see, the warnings and the errors as well. Okay, so if I remove the equal sign, it's going to be an error. In fact, there are 2 errors it shows me. Okay, as you can see, they're all over here. Okay, like this. All right, let's do this. Let's do this. Okay, so let me just show you a couple of things. Okay, so as you can see, private val and in object main is never used, and we can suppress it. Okay, so we can do add Scala and notation no warn, and we can say, for example, Well, let's actually start like this. Okay, we just say no warn. Okay, so no filters, no nothing. It is gone. Okay, the other version that we can do is we can, for example, say, okay, message is, let's actually see the message again. Okay, so for example, in object main is never used. Okay, so we can do message equals unused like this. Okay, and then bam, it's going to disappear in just a second. Unused. Did I spell it wrong? Oh, it's never used. Okay, so let's do never used like this. Okay, and now it is going to disappear. Also, notice that that we're also getting a warning if the annotation does not suppress any warnings, which is actually super cool. Okay, so let's do never used. Okay, let's also have another version of it. Let's duplicate this line. Let's remove this. So we can also do the entire category, right? This is what I wanted, right? So the entire category is actually called unused. Okay, so if I comment this in, it is going to disappear. Also, in the meantime, let me actually open the terminal and let me actually go into SBT because I want to show you this rewarn plugin. Okay, because without the rewarn plugin, every time you would compile, let's just do compile like this. Okay, so it actually would not show you this warning. Okay, so let me enable the warning. As you can see, there is a warning. Okay, but now if I save it, it still always displays the warning. Without the rewarn plugin, the incremental compiler would not recompile it and therefore would not show the warning. Okay, so it's very important. Also, let me show you if you have the bloop CLI, if you're using the bloop CLI, then if you do something like bloop compile. What is it called? Playground. Okay, so if you do this, it's not called playground. Oh yeah, playground space. Okay, so as you can see, there is no warning, and the thing is that the bloop comes in with comes with two reporters. One of them is based on a different Scala on a different SBT plugin. I forgot the name. I think it's called Error Summary, and this is the default one. But luckily, it allows you to actually change the reporter, and you can change the reporter to the same one that is used in the Scala compiler, and then whatever the rewarn plugin configured would actually work out. So all you need to do is you need to say reporter Scala C. Okay, and now you're going to see the warning, right? So even though bloop doesn't recompile, it still redisplays the warning, which is really great. Okay, I don't think that we need anything here anymore. Yeah, I'm actually going to close it. In fact, let's actually keep this one open just in case. All right, great. Let's play with it a little bit more. Let's leave this one. Okay, so let's go over here and do val stream int. Okay, since Scala 2.13, where the collections library was rewritten, stream was deprecated, and we should now use lazy list. As you can see, we have 3 warnings now. In fact, maybe let's do this for now, just so that we can concentrate only on this one. Okay, so now we're going to do the same thing. Let's start with this one. We can suppress it like this. All of them are gone. Let's duplicate it. Let's go and let's do, for example, message equals deprecated. Okay, like this, and now it's deprecated. Let's also do category, and the category is called deprecation. Okay, so as you can see, this is a compiler error, invalid message filter. So we're gonna do deprecation like this. Okay, and now there is no warning again. Let's do this. Let's do that. Let's save the file. So the next one we're going to play around with is since. So since greater to 12 like this. There we go. It is gone. Let's also do since equals to 13.0. Okay, it's gone. Let's also do to 13 like this, and it's gone again. Great. Let's comment this out. Let's comment this up. Okay, let's do a similar thing for WartRemover. And the thing is that this annotation, the one that comes from the Scala compiler, somehow it doesn't apply to WartRemover, but luckily WartRemover itself comes in with its own annotation, so we're all good. Okay, so let's start with val x equals 1337. Okay, now we're going to see WartRemover, and the one that the name of this wart is called public inference. Public member must have an explicit type description. Okay, we're an object main. This is a public, public class, public object, and therefore we have this. Okay, so if we wanted to suppress it, we would do at suppress warnings like this. Oh, by the way, recently VS Code came up with this thing that I can actually change the size of it. Finally, took years. Okay, so suppress warnings, and this expects an array. Okay, an array of the warnings that you want to suppress. Okay, unfortunately, you have to use the fully qualified name, so you're going to do org WartRemover .warts public inference like this. Okay, so you kind of have the name here. The package is always this. Okay, so you always have to write this. Okay, let me save this, and it's going to be gone. There we go. Okay, let's do another one. Let's do safe int sum 1337. Okay, now calling .get on an option is not a safe operation. However, the WartRemover is not smart enough to figure out that this is actually a sum. So this is actually a very valid use case to actually want to suppress a warning. So let's do this. So we're just going to duplicate this, go down over here. As always, the package is exactly the same. I'm going to say option partial, right? It's not a get is not a total function, it is a partial function. Now I want to actually show you all of the WartRemover warts, and I want to show you how to how to enable and disable all of them. But before that, let me actually grab all of this code and go back to dev inside you, which is this one, and I'm going to paste it. Okay, so this is pasted now, and I'm going to remove the warning annotations like this and like this. Okay, right, so it's the same template, which means that this is exactly the same Scala version and everything, but we're not going to see any warnings. In fact, we need to restart the build server again real quick. You know, like every time I'm gonna switch, I'm gonna be forced to restart the build server. Let's also open the warnings, and okay, now I'm actually surprised that I'm seeing this one, but I'm not seeing the other ones. I'm actually not sure what is happening. I'm simply going to remove this example because it is going to cause us some problems. Okay, so let's actually look at this scalac.spt file, and I want to show you a couple of things about WartRemover. First of all, it comes with several settings. This one adds things to warnings, but you could also add things to the errors. I figured that I didn't need it in the end because I could just control them with this X fatal warnings flag. As a reminder, like these settings I created on my own. This one comes from the actual plugin, and it also comes in with this object. Okay. And recently in Metals you can actually have auto completion here. So there's all, and there's also all but, right? And you can also leave it empty because it's var arg, so you can leave it like this. And then, for example, you could disable some of them. For example, you could do wart dot, and you can enable auto completion, and you can search for the one that we just had, for example, option partial. Okay, so now you have all of them but this one. Okay, there's also one called unsafe, which is kind of a weird name because it is safe to use. It just says that this is the subset of the warts that are considered unsafe for, I don't know, let's say a Scala beginner. And also they are safe in the sense of that they never produce false positives. Okay, so if you're using all of them, you know, some of them might be tricky, but then again, it's not an issue because you can suppress them. Okay, let me actually show this to you. So this is, again, this is a sequence. Okay, let's enable all of them. I actually have it open over here. So this is the ones that are considered unsafe. Okay, and this is all of them. And by the way, WartRemover actually has a very good documentation, but it's still documentation, so it still can be outdated. So if you want to see all of the warnings, well, either use autocompletion or just look it up over here. Okay, so it's, you know, github.com/WartRemover, and it's inside of core source main Scala WartRemover. There's warts over here. By the way, this whole plugin thing is called Octa3. It's a plugin for all major browsers, and yeah, so these are all the warts. All right, so we're pretty much done. The last thing that we're going to do is we're going to play with these git hooks. Okay, so again, our scenario is that we're over here inside of inside of dev inside you, and we totally forgot that we disabled all the warnings, right? So all of these, they're technically warnings. We've seen that, you know, that the compiler was barking at us in this other distribution. So what we're going to do is we're going to the well, actually, I'm going to do it outside. Okay, so we're inside of Playground, which is currently not a Git repository. Okay, so I have an alias called GI. Okay, so basically inits the Git repository, adds everything, just throws everything in there, calls it initial commit. Okay, I'm going to do GI. Okay, so now that this is a Git repository, there is actually a folder inside of it called hooks. I'm sorry, git/hooks. Okay, so if we list them all, as I already mentioned, so these are all the hooks that you can have, and they're all called a dot sample. Okay, so all we need to do is we need to, well, first of all, let's actually create a repository on GitHub first. And I have a video about the GitHub CLI, not Git CLI, GitHub CLI, and I have a couple of aliases there. We're going to use this one, which stands for repo create on dev inside you and make it private. Okay, so we're going to go up and up again. Okay, so we're over here. So I'm just going to do gh rcdp repo create on dev inside you and make it private. Okay, so we're just going to do this, wait for a couple of seconds. Now it goes to the GitHub API, creates a repository. Okay, and now we can actually do repo view web. Okay, and it's simply going to open it in my browser. There we go. Okay, so this is the repository that we just created. It is empty. Okay, so now if we go back, okay, and we do alias gp sup, I'm using zsh and with omyzsh, and omyzsh comes with a bunch of plugins. One of them is the git plugin, which is enabled by default, and it comes with a bunch of aliases, and this is one of them. Okay, so this basically pushes the current branch. Okay, now if we were to push it now, it would just push it, okay, because we haven't done anything special. However, if we actually go into git hooks, okay, do ll over here. Okay, so we're going to use this one, pre-push. Okay, all we need to do is we need to create a file called pre-push. Very important, no extensions, no .sh, no .bash, nothing. Okay, just pre-push like this. Okay, we're going to make it executable, plus x pre-push like this. Okay, so now it's green. Now it's like all of the others. Okay, we're going to just open it with Vim. Okay, I'm using NeoVim, but you can open it with any folder. Okay, so yeah, I don't care. All right, so we're just gonna make it a bash script. Okay, so we're just gonna do a /bin well, technically the shell script doesn't really matter. Okay, so now we're gonna pretend as if we were on the CI server. So we're gonna do export CI equals, okay, and we're gonna say, again, the value doesn't really matter. So we're gonna do a fake it till you make it. So now all we need to do is we need to do sbt test compile, right? Because on CI, this variable would be set, and test compile will enable all of the warnings, and it will turn all the warnings into errors. Okay, great. So this is all we need. So let's go out of here. Okay, let's actually look into it real quick to make sure that I saved it properly. Yeah, there we go. Okay, just exporting the variable, and again, like, this is like, your scripts can be as fancy as you want. You can check for for Scala FMT, you can have some fancy things that that maybe sometimes it's not gonna run and whatever, because again, like this, your every push, it's gonna take as long as a clean compile is gonna take from now on. Even though we're not doing it clean, this thing changes the build configuration. Okay, even if you were to use Bloop, you would need to re-import the Bloop build and stuff. In any case, let's go up again. All right, so let's look at the repository again, which is over here. As you can see, no branch is pushed yet. Okay, so we're going to try to push for the first time this branch. So we're going to do gp sup, and as you can see, it's a bit slow. And what is happening behind the scenes is exactly this, right? It exported the variable, it runs sbt test compile. Now all the warnings should be enabled, and all of the warnings should be fatal, and therefore it's simply going to say fail to push some refs. Okay, so if you go over here, you're going to see that it didn't push anything. Okay, so now we can go and fix them. Okay, let's just comment them all out. Doesn't really matter. So we're just gonna go over here. We're going to, well, we can actually let's just to be sure, gcam fixes all the things. Okay, and now we're going to do the same thing, gp sup, and now it's going to run through sbt as well. It's going to see that there are no errors, everything is going to be fine, and then it's actually going to push. Okay, let's see, compiling, done compiling, everything is good, and there we go. This is our push. All right, so if we go over here, we're going to see that the branch is actually pushed. There we go. Ta-da. Now, actually, I kind of forgot, like, I've been meaning to actually go and modify the previous commit, because like, this is like, the real scenario would be like this, right? You already committed, you want to push it, and then it's going to tell you that you shouldn't have done it, and so you would usually go and change the previous commit. I just created another commit right now, but like, in practice, you wouldn't do that. All right, so we're pretty much done. Let me actually go in there again, and I want to show you this. Whoa, where are we? Hold on, let's go back to playground. Let's do git hooks and bad pre-push. Okay, so I just wanted to mention that you shouldn't worry about this variable, because it runs in a subshell. So after the script is running, if you do echo, I mean, now it's gone anyway. Okay, but still, like, if you were to push and like, the script would run, it doesn't matter like how it ends. This export is not going to be there. However, SBT already read it, and therefore if you're gonna start SBT again after this, it's probably gonna invalidate all of the caches. In fact, like, this is one of those things that I'm still not super happy about. Like, I haven't really solved this issue to I don't know. I want to tell like either SBT or Bloop that it should now like, because like usually you would have like the whole project compiled, right? You kind of like think that everything works and then you push, right? And so all I want is to sort of like ask SBT to turn all the linting on and then make all the warnings, convert all the warnings to errors. But in order to do that, it has to go and recompile everything, right? So it's basically a clean compile. So I don't think that there is a solution to this. So what I would probably do is, because like very often, like I create my feature branch and I live on that feature branch for a couple of days, and then I push stuff like a maniac all the time because I'm paranoid, if my laptop dies or if somebody steals my laptop, okay? And I cannot have my pushes take so long. And so I'll probably make this script I don't know, maybe a bit more fancy. Maybe it's gonna read an environment variable, and if it's set, then it's gonna run this. If it's not set, then it's just gonna return 0. Or maybe I'll create a tiny alias that will go and rename this pre-push script to something else, because if it's something else, then it's simply not gonna run. Things like this. There are basically ways to disable this sometimes. In any case, I'm talking too much again. Take my template for a spin. Don't be afraid to change it, fork it. The license is very, very permissive. And yeah. I'm going to see you in the next one. For now, as always, it's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you. And if you learned something today, consider supporting me on Patreon or on GitHub sponsors, whatever you prefer. And also watch my videos weeks and sometimes even months before everyone else. And most importantly, take care.